Hi, advanced algebra students, Miss Corrigan here. We are going to go on with the second half of our probability unit today. So we're going to be doing day 2. And today we are going to be calculating some combinations, and we're going to review permutations as well. And we're also going to be doing some geometric probabilities. So we have geometric probabilities here. And then we're also going to be doing permutations and combinations. So we started permutations yesterday. We're going to add on combinations today. And we're going to be able to distinguish if a problem is a permutation or a combination. Okay, so looking forward to next week, we're going to have a review day, and then we're going to test on the second half of Unit 9 at the end of next week. Okay, so we'll have permutations, combinations, factorials, geometric probabilities. Okay, so that's all coming up next week. And then we'll finish off our probability unit at the end of next week. All right, so we're going to choose between permutations and combinations today. We're also going to use combinations to calculate probabilities. And we're going to calculate probabilities using geometric areas. Those are our learning targets for today. So to begin with, I have to clear all these out here. Okay, so to start with, this is a little bit of a review from yesterday. If Jill has 4 stuffed animals, how many different ways can she line up 3 of them on a shelf above her bed? So she's lining up 3 of her 4 stuffed animals. So if you think about it, she's got 3 spots on her shelf that she's going to put one of her 4 stuffed animals in each spot. Okay, so for the first spot, she has 4 to choose from. Her second spot, she has 3 left to choose from, and her third spot, she has 2 left to choose from. So to figure out the total number of options, how many different ways she can line them up, we're going to multiply these together. And so again, this is kind of a shortcut to drawing out a tree diagram. It's called the fundamental counting principle. Instead of drawing out a whole tree diagram to see the total number of possible outcomes, you can just take each independent event and how many outcomes they have and multiply them together. So there's 24 total ways that she could line up her stuffed animals, 3 of her 4 stuffed animals on a wall. Now what we're going to do today is we're going to take this and look at a different avenue to these problems. Let's say she's going to her cabin for the weekend and she only has room to bring 3 of the 4 stuffed animals. Okay, so we want to see how many different groups of the 3 she could bring. So notice the difference is she's just choosing 3 of them to put in her bag. It doesn't matter which one goes first on the wall or second or third, first on the shelf, second, third. She's just choosing 3 of them to put in her bag. There's no order that's required. So let's say her 4 stuffed animals are a dog, a bunny, a turtle, and a pig. Okay, so how many different ways can she group 3 of those 4? She could pick the dog, the bunny, and the turtle. Or she could pick the dog, the bunny, and the pig. Or she could pick the bunny, the turtle, and the pig. Or her last option, she could pick the turtle, the pig, and the dog. There's actually only 4 different groups that she could choose to bring 3 of those 4 stuffed animals with her on her trip. So lining them up in order, she has a lot more options, but just choosing 3 out of the 4, there's only 4 different ways she could do that. Okay, so that's going to be the big difference today when we talk about combinations, so the difference between permutations and combinations. Okay, in a combination, order does not matter. So before with the permutation, order mattered, but with combinations, order does not matter. But they're still not allowed for repeats. So just like a permutation, a combination doesn't allow for repeats. Okay, so the biggest difference is that a combination order does not matter, where a permutation order does matter. And then here's the formula for a combination. Okay, so yesterday we learned the permutation notation. Today the combination notation looks really similar to permutation, but it has also that r factorial divided off in the denominator. So take a minute and write this down. You're definitely going to have to reuse both of these formulas. You can use notes on the test, so it would be a good idea to write these down and have them accessible so that you can use them on a test. Okay? All right, so let's write out each of these with a formula, and then we're going to evaluate. So here again, the formula is given to you. It's n factorial divided by n minus r factorial times r factorial. So if we want to find 10c7, okay, so our 10 is our n, and our 7 is our r. So we're going to do 10 factorial divided by n minus r, so 10 minus 7 is 3 factorial, times r factorial, r is 7, so 7 factorial. Okay, so that would be our formula, that's our expression. And if we evaluate that all the way out, we have 10 times 9 times 8, 6, 5, 4, 3, 2, and 1, divided by 3 factorial is 3 times 2 times 1. So that's our n minus r here. And then 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, so that's how, if we would write this out in expanded form, that's what expanded form would look like. And then if you notice, everything, these 7s on down are all going to cancel out. Okay, so what we're left with is 10 times 9 times 8 divided by 3 times 2 times 1. So when we evaluate that, we get 120. Okay, so go ahead and pause the video and see if you can follow that same pattern and evaluate 6C4. Okay, so hopefully you were able to pause that and try that out. So 6 is our n, 4 is our r. If we follow our formula up here, we have 6 factorial, which is our n, divided by n minus r, which is 6 minus 4, so 2 factorial, times r factorial, 4 is our r, so 4 factorial. And we're going to write that out in expanded form. Okay, and then we're going to evaluate what we have left. So everything 4, 3, 2, 1 back here is going to cancel out, and we're left with 6 times 5 divided by 2 times 1, which is going to give us 15. Okay, so just note that on the test, you're going to have to write these problems out in expanded form and then evaluate them. Okay, so you're going to have to know how to expand out the formula and then find the final answer. However, when you get to something like the next problem, how many different card hands can be chosen from a standard 52 card deck? So we'll learn how to put a word problem into the formula in a minute. But if I were to write this out, I have 52 total cards, and I'm going to choose 7 of them to go in my hand. Okay, so if I were to give this formula to, if I were to give this problem to you, I would say it's 52C7. But I don't want to write that whole thing out in expanded form. That's going to be a really long list to write out and to calculate. So I'm going to show you how to do this in your calculator. But again, just know you're going to have to be able to show all these steps and use the formula and evaluate. But from here on out, you can use a calculator to enter in for combinations and permutations. Okay, so I'm going to pull up, if you don't have a graphing calculator at home, you can use, if you Google test nav calculator, Okay, so I'll share this tab with you for a second so I can show you what it looks like. Stop this one. I'm going to present this one. Let's see. And I put this in the chat if you logged into Classroom today, or you can ask your teacher for it. But if you Google Test Nav Calculator, they are offering a standalone like graphing calculator for you to use. Okay, so what you do is you click on this. Okay, so you come to this. It's like the Minnesota assessment homepage. Normally you can't access this, but because we're in distance learning, you can. But there's this thing that it's a 8 to 11 graphing calculator. So you click on that. This is what you would use for like standardized tests. When you're taking a standardized test, you have access to this calculator. Okay, so you would just click through and, start the couple questions. And then to access it, you click this calculator, Graphing TI-84 calculator button, so you're able to use it. And so make sure you have access to a graphing calculator. It's going to make your work a lot easier when you're going through this, okay? So as a reminder, we had 52C7, all right? So in your calculator, I'm going to show you how to enter this. So 52C7, you would go to this math button, which is like the third one down here below the y equals. And then you'd scroll over to the probability. Sometimes it's just PRB, sometimes it says PROB. So you hit the probability, and then you scroll down to the NCR. Notice there's an NPR also. We can use that as well. But NCR is what we're doing. We're doing 52C7. So I'd enter on that. Now I'd put my 52 on the left-hand side. Now I'd put my 7 on the right-hand side. And that's going to calculate it for you. So you don't have to use the formula or expanded form, but just be aware that you are going to have to be able to do that on the test, but this will make it easier for when you're solving these problems from here on out. Okay, some calculators, instead of doing the math button first, depending on what calculator you have at home, sometimes you have to type in that number first, 52. You type that in first, and then you hit math, and then you scroll over to probability, and then you scroll down to NCR, hit enter, and then you hit 7. So if that first option didn't work for you, just know that sometimes you have to hit the number first, and then go to the NCR, and then hit your second number, okay? You should still get the same thing. All right, so it's important that you know how to use that because you can use that for your test coming up next week. Okay, so out of a 52 card deck, there are 133,784,560 different ways you could get dealt 7 cards, which is kind of crazy. Okay, so let's go back to our notes here. So if we flip back to our notes, okay, so here we go. How many different 7 card hands can be chosen from a standard 52 card deck? Okay, so there we just solved that. All right. Okay, so the next part, we're gonna practice a couple of these. We're gonna go from a word problem into writing it as an NCR problem. Okay. So how many ways can you select a 4-member committee from a 20-member club? So this is kind of a key word here, select. If you're selecting, you're not ordering them, you're not putting them first, second, or third, you're not picking president, vice president, secretary, you're just choosing or selecting 4 people out of a group of 20. So eventually we're going to have to determine if it's a combination or a permutation. Combination, remember, order doesn't matter. So if you're just selecting 4, it doesn't matter what order you pick them in, then it's going to be a combination. So it's going to be a combination. We're going to use the NCR. Your N is always the total number of people you can choose from. It's always the bigger of the 2 numbers, okay? So you have 20 total members you can pick from. So that's your N. And you want to select 4 of them. So that's your R. So your N is always your total number set. And then your R is how many you're choosing or selecting from your total set. Or in other words, your N is always the bigger of the 2 numbers. Okay, so go ahead and put that in your calculator and see what you get. So in this case, you don't have to write out the whole formula and solve it. You can do it that way, but now that you know how to enter it into the calculator, you can use the calculator. So when you put that in the calculator, you should have gotten 4,845. So there's almost 5,000 different ways you can choose 4 people out of 20 in a group. Okay. Now here we get a little bit harder. We're going to select 4 people from a committee, a 4-member committee from 20-member club if the president of the club must be on the committee. So the wording sometimes with these problems gets a little bit tricky. We're selecting still, so we're still doing a C. Okay, we're still selecting 4 members, but however, if you think about it, sometimes it helps to draw a little visual. You have 4 people out of the 20 that are going to be on this committee, and you know the president absolutely has to be on the committee. Okay, so now we're down from 20. The president has to be on there. So for the remaining 3 seats, we have only 19 members now to choose from because we took out the president. Okay, so of the 19 remaining people that are not the president, we have 3 seats left to fill. And it doesn't matter what order we fill them in. We just need to know how many options there are for filling the remaining 3 seats out of 19 people. So you would do 19C3. So go ahead and put that in your calculator. And when you get that, you should find that there's 969 different ways that 3 members can be chosen from a set of 19. Again, then the N is always your total set or the bigger number, and your R is the number that you're choosing. Okay, so adding on to that, this time we're selecting a 4-member committee. So again, we're selecting, it doesn't matter the order. Okay, so this is going to be a C again. We're choosing 4 members from a 20-member committee, but this time the president of the club cannot be on the committee. So we're taking him out of the mix, and the treasurer must be on the committee. Okay, so we know again we have 4 seats. We're taking out the president, so we're down from 20 to 19 total options to choose from. And the treasurer we know has to be on there. Okay, so we started with 20. The president can't be on there, so we're down 1 person. The treasurer has to be on there, so we're down another person. So we have 18 total people left to pick from for the 3 remaining spots. So I'm a visual learner. I like kind of drawing on a diagram, picturing what would happen. Okay, so we have 18 people left to fill the remaining 3 spots. And then I would just put that in my calculator. And I get a total of 816 different ways I can select 3 people from the 18 remaining. Okay, last one. And this one gets a little bit more challenging yet. This time we're selecting a 4-member committee from a 20-member club, but there's 12 women and 8 men. So we have 12 women and we have 8 men. Okay, and the committee must include 2 men and 2 women. Let's see if I can fit this on my, might have to, my iPad is not letting me scroll down. Okay, so think about that for a second. Think about how we can find that. Okay, so we have a 4-member committee. So again, we have 4. But we know that 2 have to be women and 2 have to be men. Okay, so this word "and" is important. We talked about this back before at the beginning of the first half of our probability unit. When you have 2 events occurring and you want both of them to happen, that means you need 2 of them to be women and 2 of them to be men. That "and" is an important word in probability. That means that we're going to have a multiplication thing happening here. Okay, so order doesn't matter, it's a C. So of the total women, we have 12 total women, and 2 of them must be women. And we have 8 men, and 2 of them must come from the men group. So we have to do 8 or 12C2 times 8C2, and that will give us our total possible outcomes for selecting 4 members from 20, where there's 12 women, 8 men, and they have to be 2 of each. Okay, so you would just put that into your calculator, multiply it through. And when you do that, you should get 1,848. So check your work, make sure you're entering it in the appropriate way. That should be your final answer. Okay, moving on. We're gonna compare the difference between combinations and permutations. Okay, so as a reminder, both of them can have do not allow repeats, but combination order does not matter. So you don't have to have a specific order with a combination. But a permutation order definitely matters. So anytime you see the word arrange or pick first, second, then third, or gold, silver, bronze, or president, vice president, secretary, it's a specific order that they're chosen. Combinations is just selecting a group or picking a certain number out of, a group. Doesn't matter what order you select them in. Okay, so for example, if we look at these first two, there's 18 students on the math team, 5 are selected to go to the same tournament. How many ways can the 5 students go to the tournament? So they're all going to the same tournament. Doesn't matter what order they're selected in, you're just selecting 5 out of the whole 18. So since order doesn't matter in this one, this is going to be a combination. So out of the 18 total students, 5 of them are going to be chosen. Doesn't matter what order they're chosen in, they're all going to go. If they're chosen, they're going to go, right? So then you can put that in your calculator. And you're going to get 8,568. Okay? Where if you look at the next one, the difference here, this time you have 18 students in the math team. 5 students are selected. So again, you're choosing 5, but the first student selected will go to the first tournament. The second student will go to the second, and then so on. Okay, so there's a specific order. If you're chosen first, you're going to that first one. If you're chosen second, you're going to that second one. So this one, order definitely matters. So this is going to be a permutation. So instead of 18C5, you're going to do 18P5. And again, you can enter that the same way in your calculator. You're going to go to the math probability, go down to the NPR this time, and you're going to put in your 18 and your 5. Okay, and you're going to notice choosing 5 students out of 18 is a lot. There's over 8,000 different ways, but if you order them and you pick them a certain number of ways, there's a whole ton of more options because you specifically order 5 students in a different way. So this is going to be, there's 1,028,160 different ways that you can order or arrange 5 students out of a group of 18, which is crazy. It's a lot of different possibilities. That would be a nightmare of a tree diagram to draw. And that's why we have shortcuts like this. Okay. So try a couple of these on your own. See if you can determine if which one of these two, I know I didn't clear the ink from the page, are a permutation and which two are combinations. Okay. So pause the video and take a minute to try and decipher between the two. Okay, so for the first one, 8 students, you have 8 students but only 6 desks. How many arrangements can I have? So arrangements is kind of a key word. Okay, so if you're going to arrange something, it implies that you're lining them up or you're ordering them. So you have 6 different desks in a row here. You have 6 different desks, and you're arranging the 8 students in those desks. So there is going to be a specific order. So this one is going to be a P. Out of the 8 students, you're going to arrange 6 of them in a row. So when you evaluate that in your calculator, you should get 20,160. Whereas in the second one, You can take 6 on a field trip. How many different groups are there? So it doesn't matter what order you choose these students in, you're just selecting 6 of them. Doesn't matter what order you select them in, you're just selecting 6 of those, okay? So this one is gonna be a combination. Out of the 8 students, you're gonna choose select is kind of a keyword too. You're gonna choose 6 of them. So that one's gonna be 28. There's 28 different ways you can select 6 students to be in groups. Okay, again, pause and see if you can determine which one is a combination and which one is a permutation. Okay, so the first one, Aaliyah has 8 types of flowers in her garden. How many ways could she create a bouquet consisting of 3 types of flowers? So she's putting 3 of the 8 flowers in a bouquet. It doesn't say she's choosing one color first and then another color and then a third color. She's just choosing 3 flowers. So order does not matter in this case. So this would be an 8C3. And if you put that into your calculator, you should get 56. Where the second one, a grocery store carries 12 different types of cookies. Only 5 of the cookies can be displayed on a shelf. How many different ways can they be displayed? Okay, so when you're displaying or you're arranging or you're putting them in a locker or you're putting them on a shelf, there's definitely an order that goes because once you place one on the shelf, that one gets out of the mix and then you place another one on the shelf and then another one. So you can't, like, it's one and then the next and then the next. Okay, so this is a definite order. So this is going to be 12 T5, and that's going to be 95,000. Can't read my writing. 04 something. 040. I think 040. Okay. So that's the next part of your assignment is differentiating between combinations where order doesn't matter and permutations where order matters. The last little part, we just got a couple more here to do. And we're going to do geometric probability, which is a probability calculated by the ratio of lengths or areas. We're going to have to recall some area formulas from geometry. Okay, so we'll go through these together here. Okay, so for the first one, we're going to find the probability. So remember, probability is the success or what you want to have happen out of the total possible outcomes. Okay, so probability, what we want to have happen is going to go on the numerator, and the total possible outcomes is going to be the denominator. So for this first one, what's the probability that any 2 numbers, not necessarily integers, you select will be between 0 and 6 will have a sum that's less than or equal to 5? Okay, so we did something kind of like this, like with the dice thing, but it was exact. This time it's not necessarily an integer. So you can pick 0 and 5 that has a sum of 5, 1 and 4, 2 and 3, 3 and 2, 4 and 1, and 5 and 0. All of those integers have a sum of 5. But we want to find a sum that's less than or equal to 5. So from this line, anything below or equal to this line is going to be a possible outcome where you can add those two together and get a sum of 5 or below. Okay, so if you notice here, we have a triangle. So what we want to have happen is going to land within the area of that triangle, which is the area of a triangle is 1/2 times base times height, which our base here goes from 0 to 5. So our base is 5. And our height goes from 0 to 5. So our height is 5. So it's 1/2 times 5 times 5. Okay. And then out of the total possible outcomes, so we're talking about a grid, a 6x6 grid right here, because it says any integers from 0 to 6. So out of that whole grid is our total possible outcome. So that's the area of a square, which is just base times height, which is, we have a 6 by 6 grid here. Okay. And then our probability is going to be the success over the total possible outcomes. So if we multiply 1/2 times 5 times 5, we get 12.5. And then 6 times 6 is 36. So there's a 12.5 out of 36 chance that if we select any two random integers, it's going to fall within the green shaded region. And if we evaluate that all the way out, it's a 0.347. Okay, so big things to remember is the probability is the success over the total possible outcomes. Okay, so we'll do a couple more and then we'll be done for the day. Here we have a dartboard and we want to find each probability. So remember, probability is the success, what you want to have happen, over the total possible outcomes. Okay? So our whole possible outcome is this entire dartboard. Okay, so out of this whole entire dartboard, what's the probability it's going to land in the white region? So let's do the total this time first. Okay. So out of the total, which is the area of the square or the dartboard. Okay, so that's a 24 by 24. What's the probability it's going to land in the white area? So this white area is a circle right here. And if you remember, the area of a circle formula is pi times radius squared. So the area of that white circle, the radius is 4. So the area of the circle is pi times 4 squared. Okay, so what's the probability it's going to land in that circle out of the entire dartboard? So when you evaluate that, you do 16 times pi and then divide it by 24 by 24. And that is going to be 0.087. So if you want to put that in your calculator and check it, make sure you got it right. 0.087 should be your answer. Okay. The next two get a little bit more complicated. The probability it lands on red. Okay, so let's just erase this little part here. So the probability it lands on red. Again, it's out of the entire dartboard. Okay, so again, the area of that whole dartboard is 24 by 24. Okay, but this time, the probability that it's going to land on red. This is a little bit weird. Okay, so red up here, let me see what color would make this easiest to see. We want it just to land in this red. That's not going to work. We want it just to land, let's see if this one works. No, that's not going to work. Trying to find a color that'll write over the red. We want it to land in this red circle. Okay, so anywhere within this red region. Okay. So it can't land in the green or the white or the yellow. It could only land in the red. So to find that, we're going to do the area of the whole red circle. So the area of the whole red circle, so the entire red. But then we have to subtract off the area of the green and white circle. We'll just do the whole green circle because we can include that whole thing. Okay, so I'm going to do this down here. So like if we want to subtract off this whole green circle, I think I have a green highlighter. So we're going to subtract off this whole entire area in here. So you got the area of the red minus the area of the green. So the area of the red, if we take that whole entire circle the radius is 4 plus 2 plus 2, so you have a radius of 8. So that's going to be pi times 8 squared. And then the area of the whole square. Oh, I'm sorry, then we have to subtract off the green. Okay, so pi times 8 squared, and then we're going to subtract off the green, which is the green circle is 4 plus 2, so it's pi times 6 squared. So that's how we would find that. So we have to subtract off the whole green circle. And then we're going to put it out of the total area of the square, which again is 24 by 24. So make sure, like, if you're putting this all into your calculator at one time, make sure you put parentheses in the numerator and the denominator so it follows order of operations for you. And when you do all of that, you should get 0.152. So I'll pause it for a minute, see if you can work all that out. You get 0.152. That's how you would solve that one. Okay, and then finally, for, so you have to clear all of this out, the area of the yellow. So the yellow is going to be everything outside of the circle. Okay, so it's still out of the whole total dartboard, so it's still out of that 24 by 24. Okay, so we're going to still have this be out of 24 by 24. But then the yellow, what that's going to be is that's going to be the area of the whole square minus, we're going to subtract off this whole circle area. Okay, so we want to take, let's see if I can, we want to subtract off this whole circle area. Let's see if I can make this. We want to take this whole thing out of it. I don't know if it's going to allow. So we want to subtract off this entire area and the red also, but it's not letting me go over the red. Okay, so we want to take the area of the square and we're going to subtract off the area of the whole circle. So the whole circle, again, that's 4. There's a 2 here. 4, 2, and 2. Just covered it up. Okay. So the area of the square, again, is a 24 by 24. And we're going to subtract off the area of the circle, which is pi times 4, 6, 8 squared. That's all going to be on top. And then that's the area of the whole yellow region. And then divided by the whole entire dartboard. So again, if you're putting this all in your calculator at once, make sure you put the numerator in a parentheses and the denominator in a parentheses so it follows order of operations. And when you do all that, you should get 0.651. So pause it, check it, make sure you got it. Those can be a little bit tricky, but just remember the probability is what you want to have happen on top. So you have to find the area of where you want it to land over the total possible area on bottom. And that's all for today. Your assignment is in Delta Math. It's Unit 9, Day 2. Next week, we're going to have a review day, and then we are going to have the test on the second half of this unit. Have a wonderful day, everyone.